Hello, this is my video presentation for electronics. We did a infrared, well, audio to audio analog to digital, then transferred it through infrared to a digital to analog. So this is the analog in to the digital, and then these are the LED to the phototransistor connected by the light photons, and then the analog to digital. Digital to analog. And this is the oscillator that I'll talk about later. So to start, when the signal first comes in, it's like a sine wave with varying frequency to which produces the sound at different audio frequencies. So that's S in, and that is right at audio in. Then when it passes through this high pass filter, what happens is it becomes kind of choppy. As you can see by the top one, it will kind of peak it and thin it out, I guess, to make it more pointed. And the SO that you see below that, that is the output from the oscillator. So oscillator is producing a positive 2.5 voltage. Well, this is a voltage divider here, shown here. If R1 and R2 are the same, V out is half of V in. So at this point, it's 2.5 volts. And then it goes through here, and this is the positive and the negative feedback. And this is the capacitor. So what happens is, we know V plus is 2.5. So then this goes out, and it charges up this capacitor, and then when this capacitor charges up to a voltage higher than 2.5, this flops back to the other voltage of 5. That's at this output. So this is powered by a plus and 0 voltage. So this will charge between 5 and 0, and it'll flop back and forth and make a oscillating. So if it was at this, it'd make a square wave. But since we're out here, you get a wave more of like how the capacitor charges. And it charges like that. So it gets that choppy wave as well. And just like the high pass filter, charges and then discharges. So then when these two waves interact, there's not really a point, there's not points where they are similar. So if you look at the equation for a op amp, you get V out equals A V plus minus V minus. And so what happens is, if there's even a little bit of difference, A is at such a high magnitude, about 10 to the 5th usually, that it goes either +5, it goes to the reference voltages, which are the inputs in your op amp. And for us, we used +5 volts and 0. So it will create a square wave. If there's a big difference, or pretty much any difference, it'll create a square wave between 5 and 0 volts. So 5 volts and 0, +5 and 0. So the square wave is then a digital wave. What's interesting about the square wave is it's not equal all the way through because of how these interact. This is your base kind of frequency, but this widens or shrinks each one depending on like what the frequency is at the time. So going to that, that is then picked and shown out the photodiode and into the phototransistor. So the phototransistor creates, produces pretty much a very similar binary output, on and then off, because that's how it produces it. And then that goes through this another high pass filter. And since it's binary like this, not binary, well, digital like this, it'll be kind of converted to this type of signal. So when the capacitor charges real quick and then discharges, it charges to max and then discharges slowly over time. And in here, this is still slightly above like the median voltage, and then it'll charge and then discharge to slightly above the median voltage until it reaches the middle. So what that produces, so then that gets fed into this op amp. This is used to kind of select that middle voltage, so that what you get is you get the middle. So you get very little difference, and that's what this line represents here, is this constant voltage coming out of that potentiometer selector. So what you get is this is kind of like almost at 2.5, and you select, and at this is at 2.5. So in here you get just a little bit of difference, and here's this is a little difference plus, and this is a little difference minus, and this is a little different press. So it's small enough that you get more of like a slow degradation, which is what this is. So here the capacitor charges up all the way pretty quickly, and then kind of as it decays, you get into this range where this is amplifying not to 5, but it gets amplified kind of to 0, like in more of a median range, which is with this. So it produces a signal like this off through the op amp. The signal is a little choppy, so to smooth it out, we put it through a low pass filter right in here. So what happens is the high frequencies get filtered out because they'll go through here, and that produces more of a smoother wave, which is what we have here. This diode line represents kind of like the old waveform where it goes up quick and then kind of tapers down. So that's what SL would look like. That should be what we put into the speaker. It's not really that good ever, but it generally does work. One thing I'm kind of confused about, and when we did it, we took out C2, which I guess probably it's still oscillated, but oscillated at a higher frequency. I'm not really sure. And that allowed us, because before C2 we weren't really getting anything, but that might have been because we misunderstood how it outputted, how that we needed the photodiode. All right, that's my video presentation.